Hi, my name is Muhamad bin Baharuddin. So today I want to present about the torsional loadings evaluation from actual structure, which is the task for our assignment, and we select the ratchet wrench as our things to do the torsional loadings evaluation. So we go to introduction of torsion. So what is a torsion? Okay, here I want to explain what is a torsion. Torsion is twisting or wrenching of the body, that exertion of forces tending to turn one end or part about the longitudinal axis, while in the other is held fast or turned into the opposite direction. So the next meaning or example for the torsion is the twisting of a bodily organ or part on its own axis. And yeah, for the next explanation, which is the condition of twist or shear stress produced by a torque as well on a part of component. So yeah, we have some example of torsion there. So exactly, if we have some things that we twist like this, so some force we go to do this direction, and some force we go to this direction, with the different direction, so it called torsion. Or even wrench, so also called the torsion. Okay, so we go to the objective of this assignment. So the first thing one is the determine the behavior of the material that the under torsional force. So we want to identify the behavior of the material when we go through the torsional force as well. And the second one is determine stress distribution within the member of under the torsional. And the last one is to determine the polar moment, maximum shear strain, maximum force applied, and factor of safety. Which is this objective we can conclude in the calculation in this assignment as well.
Hi, my name is MASDIKA. The subject of my presentations about the applications, the main applications, a mechanism in the ratchet allow the handle to engage and tighten the fastener when you swing it in a clockwise, then determining force and direction for carrying a task. Meanwhile, in engineering applications, material are subjected to torsions in the service.
Alright, so here how the ratchet wrench works. So we use the ratchet wrench on the bicycle seats as well on the video. So here you need to use the ratchet wrench, and you need to wrench it slowly, and the seat will go downwards.
Okay, my name is WAFIY bin RASHIDI, and I'm gonna explain about the free body diagram. As you can see in these two pictures, we are using socket wrench. Okay, the force will apply at the end of the socket wrench, like these two pictures. The length of the socket wrench is 254 mm, and the torque is the direction of the torque is clockwise, and the value of the torque is 189.84. Okay, thank you.
Hello, my name is SHUHADA binti KASRI from Bmmm section 1/1. Today I want to explain about the calculations included in this project. First, we have to calculate the polar moment using the diameter of this range. We take the standard diameter of half inches, which is 0.0127 meter. Okay. For polar moment, we use the formula pi over 32 multiplied by diameter in the power of 4. So we get the answer. The value is 2.554 multiplied by 10 in the power of -9. Next, we calculate the maximum shear strain using formula shear strain equal to torque multiplied by radius over polar moment. So we use 189.84 Newton meter torque because we take the standard torque range for half square drive size. So we get the value of maximum shear strain, force 477.6 megapascal. Next, we calculate the maximum force applied using the moment equation, which is shear strain plus force multiplied by length. So we take the standard length of the wrench, which is 254 millimeters. So we get the maximum force applied is 1880.31 meganewton. So for the factor of safety, we use the torque maximum divided by torque actual. So we take the maximum range of the standard torque, which is 250 for our drive size, and divide by 140, which is the torque that we use in this experiment. So we get that the value of factor of safety is 1.786.
I beg to me again for discussion part. Mechanism of the torque is functioning as the moment of twisting structure. Axial load which produce a uniform or average stress over the cross sections. When the torque is applied to the structure, it will twist along the axis. The larger the shear strain, since twist apply a shear strain, we expect that torque will apply a shear stress. The relationship between torque is given J is as second polar of moment area of cross sections. It is referred as the second moment of inertia. Second moment of inertia are known as the area measure the beam ability to resist bending. The larger the moment of inertia, the less the beam bend. In addition, to calculate the FOS, which is the safety factor, by using maximum torque over actual torque. Based on the value of we calculate, FOS is 1.786. It can be proved that the shaft is very safe when it's being used.
Okay, for the conclusion of this assignment, first we had chosen the socket wrench as the structure to study about torsional. Second, we can finally achieve to determine the behavior of material under the torsional force, which is the torque is applied through the structure and create a twist along the rod. Next, to avoid failure, we determine the product's quality based on its material. We have calculated the maximum shear strength, which is 477.6 megapascal, to evaluate the structure that was used. Lastly, we had applying too much force on the socket wrench that can strip the screw or cause the socket wrench to slip. Then we have calculated the maximum force applied, which is 1880.31 mN. So the socket wrench will break because the force we had applied is more than the maximum force, which is 1880.31. That's all from me and that's all from us. Thank you for watching.